Get started. Just want to say hello to everyone. Thanks for joining us for today's webinar on adding real-time analytics to your performance tests, JMeter integration with InfluxDB and Grafana. My name is Bill Hayduck. I'm the founder and CEO of RTTS. I have with me Niles Burnaby, who will be presenting today, and James Kim, who will be monitoring any questions. Niles is the senior performance engineer, and James is the director of our performance engineering division. If you have any questions during the webinar, please type them into the chat window and we'll get to as many as we can at the end of this webinar. Also, please use chat to alert us if you have any issues seeing or hearing this session. Thanks again for your time and participation. And now we're going to get ready to start. So Niles, could you go on to the next slide, please? And Liz, I'm assuming we're recording.
Yep.
All righty. So this is a little bit about RTTS. We're the innovative QA and testing firm. We've specialized in test automation since our beginning in 1996. It's actually our 28th anniversary this year. We're based in New York City. Our profile of customers is North America, primarily the Fortune 500 and mid-sized firms. We've had over 700 customers in the last 28 years. We have strategic partnerships with IBM, Microsoft, Oracle, and a bunch of other players in the space. And we support a lot of different tools that are out there in the marketplace. Also, all of our engineers are computer science grads. So if the tools that are out there in the marketplace currently do not support what we need to help a customer with, our guys will build it in a utility out of Java or C++ or whatever. We'll make it work. Next slide, please. Yeah, here's a quick list of our 700 plus customers, a sampling of it. As you can see, we've worked in pretty much every major vertical. If you want to see the full list, it's on our website. Next slide, please. Here's a little bit about Niles. Niles is a senior performance engineer. He's been working for RTTS for a few years now. He works primarily developing strategies to uncover potential bottlenecks and to validate and enhance overall performance of someone's application and architecture. He's currently working in the utility space, and he's using automation tools to analyze and evaluate applications and architecture, and looking at defect metrics, and also adapting new tools and technologies to get the assignment done. Next slide, please. All right, so I'm going to turn this over to Niles. He's going to tell you about how we add real-time analytics to do performance tests. Niles, all yours.
Thanks, Bill. As he mentioned, today we'll be covering how integrating InfluxDB and Grafana into our performance tests can benefit real-time monitoring. First, let's talk about the basics. JMeter is an open-source Java-based performance testing tool used to compose test scripts and generate load. This is a protocol-level testing tool, which means that it interfaces with the application at the HTTP level. We use this tool to load test functional behavior and measure performance. There are two different approaches when executing a load test with JMeter: GUI and non-GUI executions. The non-GUI execution is the recommended approach, as it avoids high resource utilization, which could adversely affect load generator health. You can see an example of a non-GUI execution with the image here at the top. As you can see, we are unable to examine real-time results effectively as it only displays raw data. Next is the GUI execution, for which plugins are available for real-time graphs. You can see an example on the bottom image. There's still readability issues with these graphs, especially with multiple data points, which can negatively impact readability. There's also limited customization, which can lead to issues with more complex test plans. This approach is also resource intensive, as it does not scale well for heavier loads, since it requires an additional listener to be added to the test plan. Other limitations for both of these approaches is that we cannot home into specific time intervals, and real-time metrics displayed span the entire test duration up to the current moment. To address these issues, we integrate two tools into our performance testing stack. First is InfluxDB, which is a time series database optimized for fast, high availability storage and retrieval of time series data in fields such as operations monitoring, application metrics, IoT sensor data, and real-time analytics. This tool is capable of ingesting millions of data points per second, and data retention can be toggled to temporary or permanent to allow review and post. Grafana is an open source data visualization and monitoring solution. We use this tool to compose observability dashboards, which can interface into multiple types of data sources, including InfluxDB. This tool integrates into each data source using that source's native query language. Besides the benefits to real-time monitoring, this approach also allows users to author annotations, organize and store centralized historical data, easily share dashboards with team members, enhance customization, and also we preserve load generator health with this, as the solution is highly scalable. Implementing this solution is somewhat straightforward. First, we install InfluxDB and Grafana onto our machine. Then we create the JMeter database within InfluxDB and configure the protocol. Next, we add InfluxDB as the data source and set the query language within Grafana. Finally, we configure the backend listener within JMeter. There is an out-of-the-box implementation of InfluxDB listener available. However, for this demo, we'll be using a custom plugin to interface with the database so that we can send additional metrics to InfluxDB, such as network I/O, virtual user count, and test start and end time. One of the benefits that I mentioned earlier is enhanced customization. With Grafana, we can create visualization dashboards. Dashboards are comprised of panels, and each panel can be customized to meet monitoring needs. But panels have multiple visualization options, including time series, alert lists, stat panels, bar and pie charts, data grids, logs, and many others. Custom querying is required for these panels. However, extensive documentation and tutorials exist online. Users can also save multiple dashboard templates to fit the need of any project. We will go further into detail into dashboards later during the demo. Another benefit that I mentioned was annotations. Annotations provide a way to mark points on a visualization with rich events. They are visualized as vertical lines and icons on all graph panels of a dashboard. When you hover over an annotation, you get an event description and event tags. Users can also add regional annotations, which is useful for visualizing specific time intervals of load tests, such as chaos testing. This data is saved long-term for use in analysis. And now we'll get into the live demo. For this demo, we'll be running a load test against a demo pet store application online. First, I will demonstrate how to create a dashboard within Grafana. Simply go to Create, Dashboard, Add New Panel. For this example, I'll be creating a stat panel, which will display the average response time of a specific type of transaction. As you can see here, the data source is already set to InfluxDB. Here's an example of what the table looks like within InfluxDB. There are multiple columns, including time, timestamps, request names, response time, and whether or not that request failed or not. We can write a quick query, such as this one. And here, we're simply selecting the average response time in seconds from that table using our time filter and our name filter. We click apply and the panel is created. Now I can show you what this looks like populated with data. Here's a template that we often use during our performance tests. I can pull up some historic data from a load test I ran about a month ago and zoom to that time period. Here's that panel that we just created, but with data now. As you can see, it displays the average response time for the entire duration of this load test. This dashboard is comprised of multiple different types of panels. Here we have stat panels, a gauge panel. We also have line panels that track duration, throughput, and error count throughout the entire test. And at the bottom here, we have a data grid that aggregates all of the data for all of the requests. I'd also created an annotation here for the halfway point. Now let's start the load test. To give a quick overview over this script, this is a simple script with 4 transactions broken down into different pages. These pages hold the different requests for the application. As you can see here, for the out-of-the-box solutions given by JMeter for tracking live metrics, we have multiple different types of charts and some graphs. However, as you can see, readability is still an issue even with this simple test plan. And we're not able to extract much good data for use for analysis here. Instead, what we do, I can pull up this test, zoom to the data, and track as data comes in live. You can see how it auto updates. And that concludes the live demo. You can view these slides and find out more information about RTTS on our website. Thank you.
All right. Thanks, Niles. Now we're going to take some questions. So if you have any questions, please put them into the chat window if you haven't already. James, what questions do you have for Niles? I don't know.
So we'll start with our first question that we got. The question is, can these tools still be implemented in a distributed load test?
Yes, this solution still works when running a JMeter load test with the worker controller configuration. Just like in a conventional distributed load test, the result data is stored in a central repository. For high volume load tests, it is recommended to isolate the InfluxDB instance to its own server so it doesn't impact the controller machine.
This was actually a 2-part question, and the follow-up question is, are there any drawbacks to this approach when running a distributed load test?
That depends primarily on the complexity of the performance test plan and the machine resources. However, because this approach does require the inclusion of a dedicated backend listener in the test plan, this can negatively impact throughput in large distributed load tests.
Another question that we have is, what other types of data sources does Grafana support?
There's a full list of supported sources and documentation on Grafana's website. However, other sources include Microsoft SQL Server, Google Cloud Monitoring, and Amazon CloudWatch. While some of the data sources included are out of the box, an enterprise license may be required, such as when trying to connect to AppDynamics.
Okay, so it sounds like not only can we monitor, our JMeter performance test results, we can also monitor the application that we're testing. The next question is there a way to easily share results with team members?
Yep. Grafana can be configured to add additional users so they can have read access to the same dashboards. They can search for specific test results, or you can provide a link to the dashboard.
There's another question. Can other users see annotations created by another user?
Yes, the annotations are visible to other users when zooming into the results of a specific time frame. This can help track observations made when a performance anomaly is encountered.
Using this implementation, does it support any other database than InfluxDB?
Yes, you can use another time series database such as Graphite. However, this might not be supported on the plugin that we used, but you can use the out-of-the-box implementation.
Generally, how much time should I expect to spend setting up this integration?
There is online documentation which you can follow with step-by-step instructions. So I'd say setup for the tools themselves might take up to an hour. However, deciding what metrics you want to be collected and how they will be visualized on the dashboard will probably require much more time and consideration.
And the last question that I see here is, what are the main challenges I might face when setting up this integration?
So one of the main challenges that I faced when setting this up was making sure that my samplers in my script had good naming conventions so that the queries that I wrote in Grafana would be able to obtain the results and correct transaction types that I intended. For example, those business transaction pages and requests that I showed in my script.
I have a question. Just to be clear, these are both Grafana and InfluxDB are open source, so anybody is free to download them, correct?
Correct. Both of these products are open source.
As is JMeter.
Yes.
Cool. All right, I think that does it for all of our questions. Thanks everyone for your time and participation today. We will be sending a follow-up email to all participants with a link to the recording, the slide deck, and our contact information if you have any additional questions. And all this will be located on our website. So thanks again, everyone, and have a great day.